Okay, now our OpenShift cluster installation is done. You can see the green bar is showing no error here. Everything is good. Our all nodes are up. Everything is installed, and event logs. I can see all the logs here are very good. There is no issue. All the nodes rebooted multiple time. Lot of things done on the background. You know when uh, I did the session on Kubernetes, I showed you how to install the Kubernetes. So there are a lot of steps. All are done automatically, but Kubernetes is the OpenShift is based on Kubernetes. So Red Hat customize a lot of things on this Kubernetes to make it to define that is the product from Red Hat named as OpenShift. So OpenShift, you can say the Red Hat Kubernetes. So a lot of things installed on the background. Everything is automated, and you just need to take care of the logs, look the log, and troubleshoot the things. So now this whole cluster state, you can see how much CPUs, compute resource, worker node, everything is mentioned here. The detail architecture and what seeder you define for the your CNI network, for the service network. Okay, and uh, now I would like to share you one more thing. While I pause this video, because it took about more than 30 minutes to complete the installation, so I found an error, and I found two errors. So I would like to explain you that I update also the documentation and the description, the video description. The innate netting dev that I enabled on the load balancer that is providing the internet to the my master and worker nodes is not making the persistent IP table rules. So what I did to make it persistent, I installed these two packages, enable these three services. This is the netting rule I showed you. This is to list the netting rules. This command you have to run to make the persistence of your uh, IP table rules, whatever you wrote. This is to flush the IP table rule, if delete the IP table rule if you install something wrong. I mean, if you define some wrong network interface, you can flush it and you can create new one. And then you have to save it. And then rest of all is thing. One, this thing is change. And second thing is the in the HA proxy load balancer. I did a mistake in the in the first video. That is uh, the load balancer HA proxy command I showed you, the HA proxy CFG. So here this open OCP machine config server. So this is for the bootstrap server. This is a bootstrap port. You can say it will open on all the master node, and all the master node will communicate with each other using this bootstrap uh, service running on this 22623 port. And what I did, I defined here the wrong IP. You can see this is the wrong IP. So in fact, this IP should be like this. So I modified this one and I upload in the Git repo this updated file. So if someone took the older file, just replace this file. So I updated the HA proxy this file because the load balancer, when during the installation, all the master node were trying to request to our 10.10.10.1 IP, that is the gateway that is working as load balancer, to access this port, and it was not reachable. That was giving the error. So then I look into the log, I found that this port is not reachable. Then I check the HA proxy, and the HA proxy was pointing to wrong IPs. So now these IPs are good. So these things I changed in the HA proxy file in the under the this location haproxy.cfg here, and then I just restarted the haproxy service. So then everything went good, and then I also opened this haproxy load balancer page, that is showing me the, if I zoom in this page, you can see, let me zoom in. So here you can see the API front end. All the master nodes are green, and then this config port double two the double two 623 port. This is also up. Here you can see on all master node. So during installation, you will see gradually these worker master nodes will enable the API server, and then it will start greening on multiple randomly. And then this port will enable, and the ingress port is also enabled. So ingress port 80, I defined that is only enabled on worker node, not on the master node. So, but in Kubernetes, when we enable the ingress controller, we create a node port. So node port, is open across the all master and worker node in the cluster. But here in OpenShift, it's customized. It's something like a daemon set that is running only on worker node that is opening the port 80 and 443 for the ingress controller. Ingress controller is by default configured within the Kubernetes cluster, this OpenShift cluster. And its monitoring is by default enabled. I will explain you everything what is built in. So this is good now. And the second thing after the installation, I have I this installation is giving me two things. Web console URL. The OpenShift also have its own web UI, but Kubernetes don't have. So Red Hat designed their own web UI to manage the OpenShift cluster. And to log in the web UI, this is a username and password. So from here, you can copy the username. So if I click this link, it will open this login page. So default login is kubeadmin, and this is a OpenShift administrator account. So now this dashboard is logged in, and you can see the whole dashboard health status, the OpenShift cluster health status from this dashboard. The another thing I got is the download kube config. And kube config is only available to download from this place after the installation of cluster till 20 days. After that, they will delete this. So you can log in with two ways, either with web UI or either with kube config, whatever I explained in the Kubernetes section. But you can also use this URL to log in by the command line. I will explain you everything. So what you need to manage by the command line. So it is still trying to log in. Let it be log in. Now here on the left screen, you can see there is a download section. So download section, if you go, so here you can see a lot of tools are provided by Red Hat OpenShift for its administration. So OpenShift cluster command line interface, it's OC. OC I think stands for OpenShift command line. So just like we use the kubectl, we will use OC binary to execute the to execute to connect with our Kubernetes cluster. So OC is same like the kubectl command, but it has more features. Okay, then I selected Linux, and then I download this OC tool. There are a lot of other tools. We will see these gradually when we will proceed with our OpenShift cluster administration. So far for the command line administration, I download OC, and what I did, I uh, download this OpenShift client Linux T tar gz, and it gave me this OC and README file. When I extract it, so this OC is a binary file, and this is more robust. It has more feature than kubectl. Kubectl is from Kubernetes, but OC is designed by Red Hat OpenShift. I will show you how this is different. So then if I show you this README files, README explains us the OpenShift client OC simplifies the working with the Kubernetes and OpenShift cluster, offering a number of the advantages over kubectl, such as easy login, kubeconfig file management, and access to the developer tool. The kubectl binaries, including alongside for when strict Kubernetes compliance is necessary. So kubectl is only for the Kubernetes one, but you can still use kubectl, but you will have the limited feature access to the cluster. So OC is good tool. So now it is saying that just copy this OC binary and put it under the USR local bin so that it will become a command on your machine. So now if I run the OC, so I can see I am able to run this command and OC get nodes. So I can see the nodes. But when you will run this first time, it will not run because first time you will not have your kubeconfig file. So what I did, I create a cube.cube directory inside the home directory with which whatever user you are using on Linux. And here I copy the downloaded kubeconfig file with the name config. So by default, it is looking for kubeconfig environment variable or this file under the cube directory to authenticate with the Kubernetes or OpenShift cluster. So this is the default behavior of kubectl and OC command. So when you must have to place this file with this name, and then you will be able to connect with your cluster. So now I can see my cluster status. Everything is good, up and running. Kubernetes version is 1.24, and if I don't have this file, for example, let me just config backup. Okay, so OC get nodes will not run because kubeconfig environment variable is not defined. Either this file is not available, or either we can provide OC get node kubeconfig and then the path of the kubeconfig. Just like, sorry, kube, I am already in the kubeconfig. So I just need to provide the file or a file name, then I can use this file for the authentication. But if you don't have this file, even though you can log into your cluster, right now OC get nodes is not working. So I can use OC login command. OC login command is used to log in from your web UI by using the command line. It will directly hit your API server, and you can provide the username, password, and then you can log in. So what I will use OC login and hyphen hyphen help. Okay, now need a hyphen hyphen help. I will define HTTPS and then the IP of my load balancer. So I am sitting on the other side of load balancer, the second interface. So I will use 1.2.3.50 pointing to port 6443 to log in on my Kubernetes cluster by command line if I don't have the kube config. So it is saying that you are using HTTPS and your certificates are self-signed because these certificates, this page that I access, you can see the certificate is not signed. So that's why it's giving me this error. So no problem. I can say simply I want to use insecure. Okay, so the previous version of OpenShift was using here the username password based authentication, but now in this new version of OpenShift they upgraded the authentication method They are saying that straightforward go to your dashboard, log into the dashboard, and in the parallel, so I create this session, so I can open this link. This link is also pointing to my load balancer. So this link that I opened, console OpenShift console app DevOps cluster one.local, and this link I open uh, OAuth OpenShift apps. These both links I showed you in the DNS section, that these both links are pointing to my load balancer. But as as an OpenShift administrator, I am sitting on the other side of the load balancer, that is WAN side. So then I can use either the DNS of my load balancer, or I can add the in my I can open the notepad, and you can add in the etc host file. Let me show you how I did. So I am not using the DNS of load balancer because I have not enabled the TNS service on load balancer WAN port. I only enable on the OpenShift network. So what I will do, I open, and here, in the Windows etc, there is a host file. If you don't have DNS, so you can make the entry in your host file. So what I did, I pro the WAN interface of my load balancer pointing to this URL, and WAN interface IP of my load balancer pointing. So now my machine knows when I will type in this browser, it will automatically resolve to this IP. So that's why I am able to open this page. You will also get this issue that you just need to make an entry in your host file. Okay, now we are logging on the dashboard. You can see these are all. This is the complete dashboard. We will do this in the administration task of OpenShift cluster. I don't want to explain you here. Uh, this URL that is given by my command line, I just type, and I already had a session with my OpenShift cluster. That's why I use the existing session. But if you are not logged in, then it will ask for the username password, that is kubeadmin. The password you have to save, that is provided at the time of installation in the cluster. So now you can see this token is generated. Now we can use this whole command, and this whole command will not work. Why? I will explain you. Because uh, this yeah, it's because this name to API DevOps, yeah, it will work because I am working on the load balancer. Let me just retype it, and here it's asking for yes, and now you can see I am logged in. So you have accessed 72 projects, a list of the space, and now I am logged in the OpenShift cluster. Now I will run OC get nodes. You can see I am connected. So there are two ways to log in, either OC login, or either I can use the kubeconfig file. So kubectl login is not a command, but OC login is a command. So that's why OC is from Red Hat OpenShift, and it will provide the relevant commands about the OpenShift. So with the token method I use, and I logged into my cluster. So my cluster is now up, and I can see my cluster in OpenShift. You can see the projects, OC projects. These are all the projects. Or you can also type OC get projects. These are all the projects. Actually, in OpenShift, OC get namespace you can also type. These are the namespaces. So project or the Red Hat OpenShift use the name project to the namespace, but still you can use the namespace. So either you use project or namespace, both are same. So now I just want to show you that I am able to communicate with my cluster. My cluster is up and running, and if I show you just as command OC get pods, all the namespaces, you can see a lot of uh, pods are running. How many pods are running? Just I will run a word count. About 252 pods are running. But when we install the Kubernetes, we just have CNI related pods, the DNS pods, API scheduler, etcd, and what else we have? Uh, kube proxy. Okay, so these were the mandatory to run, but OpenShift by default gave us a lot of things, just like this dashboard we are trying to access. It is deployed as an operator, just like the ingress controller is by default built in, and just like the monitoring system, I will show you later. But everything is in this cluster is running uh, as an operator. So that's why the requirement of compute resources are at least what I showed you uh, in the documentation to run the cluster properly. But in Kubernetes, we just use one master node and one worker node with 8 GB RAM. Even we can deploy the whole Kubernetes cluster. So this is a vendor-specific product. That's why it need more resources. Okay, and a vendor also hard-coded that it cannot run without with the three master nodes. At least three master nodes are required, so that in case of failure, you have your cluster recoverable. So now I explained you everything about the installation method. Let me check if anything else is left. Our cluster is good. Okay, I showed you to log into my cluster. I showed you this proxy dashboard. Just a minute. Yeah, this proxy dashboard. I explained you the ingress controller is not running on the master node, and that's why service is not exposed. And this dashboard will show you your cluster health after every 10 seconds. And here you can see on the very first dashboard how much CPU is so far consumed, memory consumed, file system, total space in the file system, bandwidth, number of pods, 184 are running. And we have 5 nodes, these number of pods. And we don't have any OC get storage class. We don't have any storage class. So why we don't have? Because we install the OpenShift on-prem. When you will install the OpenShift on cloud, or you are getting the just a service as an OpenShift from any cloud, then you just need to click I need the OpenShift. They will deploy everything. They will give you the kube config file and the username password. Then you can start your administration. So everything they give you pre-built in. Storage class, you can use the storages from the cloud, whatever cloud you use. But this is the on-prem. So for on-prem, you have to configure your storage class by yourself. And this storage class we will use in the next session. I will show you. Uh, we will use the NFS. NFS storage class to to make the persistent volume within the cluster for the pod. And OpenShift also have OC get projects. Let me just check. IGIST registry. Yeah, OpenShift image registry. So this is the namespace and OC get all hyphen and this registry. You can see the OpenShift is providing you the imaging registry built in. You don't need to use the any Docker Hub. Uh, so everything is built in. This service is running, this is cluster IP service, and its daemon set is running, its pod is running, replica set deployment. Let me just check for the uh, pods. Yeah, pods are running in the image registry. So uh, so these pods, it will provide you the complete image history, but it need a persistent storage. So far, we don't have persistent storage. It is not running properly. So we will set up the persistent storage. We will use the NFS storage class. We can use GlusterFS or SAF, other storages on-prem, but I will show you the NFS based, and then we will integrate those storage classes with this image registry, because when you will push the images, when you will create the CI/CD pipeline, so you will use this registry and you can upload your push and pull the images from this registry. So that's why it need a persistent storage. Okay, so this I showed you, and now here uh, on this cluster side, if I open this cluster, so here in this cluster, you can do further administration of this cluster. For example, you want to the monitoring, you see the alert files. So whatever the Prometheus is running, the uh, the Prometheus is running, and exporters are running on the worker nodes for host-based monitoring, for pod-based monitoring, whatever is running. They all are sending live updates to this dashboard that is online from. So because your machines are online, when they will be offline, this dashboard will not be updated. So everything is updated here. Only one warning is reported so far. Cluster operator health, you can see from this dashboard. You can also see live from this location, the operators, installed operators. Okay, so so here you can list down all the operators. Uh, in what namespace you want to see all the projects. So similarly, resource usage. So this cluster is online and it is reporting everything to this Red Hat Cloud dashboard. And now if I access control, we can create here access control. I will show you later. Cluster history, sport. We don't have any sport. Add host. Here we can create further host within this cluster. We can generate a new ISO that will be supported by the same cluster, and generate. You just have to provide a DHCP based network or static IP. You can embed. If you use a static IP, I will later on show you the installation of OpenShift cluster with a static IP where the ISO file will have the IP fixed within the ISO image. So generated the discover image you can download, and then you can create a new virtual machine, and you can add a MAC address in the DHCP what I showed you, and then your machine will be updated here. And then you can select the role of worker and master node, then you can expand your cluster. So uh, this is about the orchestration of the cluster, and this is about the dashboard, and this is about the HA proxy, and this is about the token I showed you, and so we are done with the installation part. Now it's up to you. You have to practice. If you have any question, you can contact me on my email, and in the next sessions we will continue with the OpenShift complete administration. So this will be lead to, if I show you what is the scope of our this at OpenShift training, you can see Red Hat EX280 exam objectives. So here, uh, Red Hat link I want to show you. This is coming from. So here the You can see so our target is actually the Red Hat EX to Red Hat Open Shift Administration exam objective. Yeah, this is the right link that is we're looking for. So this is the complete exam objective, and the objective in the objective, these are all the exam objectives. So we will go through all these topics greatly in this OpenShift administration task. So I think you are good now. And if you have any question, you can contact me by my email.